lot with the past exam, which most of you did really well, so you didn't struggle. But if you did and you don't have that sequence down, that grams to moles to grams, this is going to be difficult. Okay, so you might want to talk to me, get with me, go next door over here and see somebody in there for help, or in lab today I can try to even help you, because this is going to be hard for you to get if you didn't get the sequence from the past unit. So, but most of you did, so I've got your exams. I'll give those back as well. You guys did really well. The bonus points really helped some of you, so good job on doing the bonus work or being here for class. So, but I'll give those back, and you can ask questions if you have it later. Okay. I've combined section 3.8. So we already looked at chapter 3, but we didn't look at this section. Okay, and I combined it with 11.1. And the reason I did this is because they're the same calculation. So you might as well go ahead and look at it and see it now when they go together. So they're just called something different. It's only really difference there. Okay. So when we deal with solutions, okay, now we're dealing with liquids, right? And so we have to be able to give some indication of how concentrated a solution is. Okay, for example, there are reactions in the lab that will work efficiently if the concentration of your solution is, let's say, 0.1 molarity. Okay, if you change it to 0.2, it might not work or work as efficiently. Okay, so this becomes a really important factor for chemists when they are, especially when they're trying to come up with new reactions. One of the things that they'll do in their methodology is look at the different concentrations and change them and see how it affects the rate of the reaction or how efficient the reaction is. Okay, so this is a very important factor. You can learn the hard way when you're in chemistry, or if any of you go on to, because you'll just kind of rough estimate on a concentration, or you dilute it to a certain concentration, and then your reaction won't work. You have to be pretty precise and accurate when you're coming up with these concentrations. Okay, molarity is one of the ways that we can express concentration. Okay, one of the other ones we talked about was our percent by mass, right? Our weight percent, part over whole times 100. Okay, but the one we're going to spend most of our time looking at is molarity, and then we'll add to this later. Okay, molarity is moles of the solute. Okay, does anybody remember what the solute is, or what our definition of it was? Remember? Okay, in a solution, is it present in the most amount or the least amount? Remember? The solute? The least, exactly. So if you have a salt solution, the salt, the sodium chloride, is the solute. Okay? Then if you dilute it with water, then water would be called what? Your solvent, exactly. And it's aqueous if it's in water. So we call it an aqueous solvent there. Okay, so moles over liters of solution. Okay, and then you can use millimoles over milliliters. These are the same. See, they equal molarity here. Okay, the only difference is millimoles is 1/1000th of a mole. Okay, so, and then here's milliliters. So if you use millimoles, you have to use milliliters. Okay, those go together. Okay, so we've already seen this slide, but here it is again in case. All right, one of the main reasons that molarity is commonly used is because we can rearrange that equation. Okay, so if we think about this, if we have molarity equals moles per liter, okay, when we're doing our sequence from grams to moles to grams when we had a solid, okay, our first step, the whole point of it is to get from grams to moles, right? Okay, because then we can compare our mole to mole ratio. Okay, so that's why this is going to be important to us, because we can take molarity times liters. So if we rearrange our equation here, little dots for rearranging. Okay, so we move our liters over there. Molarity times liters equals moles. Does everybody see how that rearranges? Just simple algebra there. Okay. So we can take the molarity, or the concentration of a solution, times its volume and get moles. Okay, so instead of grams to moles, okay, we're going to take molarity times liters to get moles. Okay? All right, we can rearrange further. So liters is equal to moles over molarity as well. Okay, so that's our second way. So we have three ways we could write this. Molarity equals moles over liters. Molarity times liters equals moles. And moles over molarity. Okay, so that will be useful to us as well. Okay, so the first calculation we're going to do, and this is on that sheet I passed around. That way you don't have to write down the problem. You can just fill it in. So this problem right here is the exact same problem. So those of you that came in late, there's sheets that were going around. I don't think anybody have them? Oh, gotcha. So nobody had the, okay. Well, you'll have to copy it or get next to somebody that has it. All right. Okay, so this is the simplest problem so far. This is what you would have had on the last unit, okay, on the last unit exam. Okay, it wants you to calculate the number of moles of sulfuric acid in 500 milliliters of 0.324 molarity. So notice that capital M, that means molarity, not moles, okay, of sulfuric acid solution. Okay, so this is just a problem like we would have done from last unit here. I don't know what this thing is. I may have to just go to the board. Okay. Okay, we're looking for the number of moles of sulfuric acid, and we're given a volume and given the molarity. Okay, so how can we rearrange this to solve for moles? Moles equals molarity times liters. Okay. All right. This right here. Okay. Once we build on this and we get our calculations get longer and longer, our sequence gets longer. That's all we're doing here. This first step that we're about to do is what we're about to do in our problems that are longer. We're just taking our molarity. Okay. So the molarity here is 0.324, right? Okay. If I'm going to find moles and not millimoles, okay, so that kind of confuses students at first. So we'll just find moles here. Okay, then we're going to need to be in liters, right? Okay. So which way am I going to move my decimal to get 2 liters from milliliters? Got to move it to the left, right? How many places? 3, exactly, because there's 1,000 milliliters. So 1, 2, 3 gives us 0.5. 0.00 liters. Okay. Okay. I'm going to rewrite this another way just to show you. So most of the problems that we've been doing when we've been converting, okay, we've had things cancel, right, in our numerator and denominator, so everything matches up. Okay, so if we write this, so let's take, doesn't matter, but we'll just do the liters first. Okay. Okay. We can also write it as 0.500 liters times 0.324, and then molarity is what? What's its definition? Moles per liter, right? Okay, so if we put moles over liters, okay, liters cancel and we're left with moles on top. Okay, so this is actually, I should have written this first, okay, what we're going to be doing in our first step to what's kind of our new sequence today. Okay, we're taking volume, liters, times, this is molarity, right? So anytime you see molarity, if it helps you, you can take that capital M and right beside it, moles per liter, okay, because that's what it is. Okay, and then our liters cancel, and we're left with moles. Any questions on this first step here? All right, now we're going to throw in a reaction. Okay, so anytime you see a reaction, of course it needs to be balanced. This is already balanced for you. Okay. And this time we're looking at a solution. So as you notice here, we have aqueous, AQ, that just means an aqueous solution here, meaning in water. Okay. And this time we're given grams for our starting, so we're given 2.792 grams of sodium carbonate. So that's right here. Okay. But we're trying to find the volume of sulfuric acid. Okay, so what we're looking for, okay, we're given this. We're looking for that. So what do we have to do if we're given something, or we know a quantity about one of our components of a reaction, but we want to convert to something of a totally different compound? What do we have to do? Y'all said something, I couldn't tell. Do what? Okay, we're going to have to use our balanced equation, right? Okay, the only way we can relate sodium carbonate, which is what we're given, and then we're trying to find sulfuric acid, the only way we can relate those two is by the equation, right? Okay, so we're going to still do that mole to mole ratio step that we've been doing. Okay. In this situation, sodium carbonate is a solid. Okay, so we're given in grams. So you'd go over and you'd weigh that out or take the mass of it on the balance. Okay. If you're given grams in one of these scenarios, okay, that's where you're going to start. Okay, we know that we can get from grams to moles pretty easily, right? Okay, so that's where we're going to start. Okay, because we're given this number here, but that's not really a starting place. We don't have anywhere else to go with that. Okay, so we're going to start with our 2.792 grams. Okay, so how do we get from grams to moles? Okay, you got to add up the formula weight, right? Okay, so if we add up 2 sodium atoms, 1 carbon, and 3 oxygens, we get about 106. Okay, so you can check that when you're studying here. Okay, and that's always out of 1 mole. Okay, some of you on the exam put something other than 1 here. Okay, remember, when you add up the formula weight, or the molar mass, if you want to think of it that way, okay, it's always out of 1 mole, no matter what the compound is. Okay. All right, so our first step, we went from grams to moles. Okay. All right, so nothing really new about that. We've been doing that for a while. Okay, and then we're going to go from moles of our sodium carbonate to moles of sulfuric acid. Okay, because that's what we're trying to find, right? Okay. So to do that, we know we have 1 and 1. So it doesn't really change anything, but we're going to go ahead and put that in here anyways, just to show it. So we have 1 mole sodium carbonate and 1 mole H2SO4. Okay, so this is the only step. We could have had more than, 1-to-1 ratio. We could have had a 2-to-1, 3-to-2, whatever it might be. But we don't, because our ratio up there is 1-to-1 for everything. Okay? grams cancel. Okay, so the only difference in this problem versus what we've been doing is the last step, right? We've just gone from grams to moles of what we're trying to find. Okay, but what are we looking for ultimately? What's our goal here? Not molarity, looking for volume. Okay, so normally you've been looking for grams, right? You've been converting to grams using the molar mass. Well, this time we have a solution. So I don't want to know how much it weighs on the balance. I want to know how much to put in my graduated cylinder, okay, or whatever my device is for measuring the volume. Okay, so the only other piece of information, what are we given in the problem that we could use to help us find this? Okay, so if you look up here, we've got 0.324. Molarity is the same thing as what? Moles over liters. Okay, so if we look at our conversion, what has to be our units down here? Moles. Okay, so that helps us out. Okay, so if this is the same as writing 0.324 moles per liter, there's our next conversion factor, right? Okay, so if we plug it in, are we going to plug it in this way, or are we going to have to flip it over? Okay, so we can flip it, so we could say this, right? Okay, we need moles here, okay? So we're going to have to plug it in this way. Okay, so we're going to take our 0.324 and put our liter here. And that's just understood to be 1 liter, so if you want to write that, you can. Okay, and that's still H2SO4. Whoops. Okay. First 2 steps, exactly like what we've been doing. Grams to moles of what we're trying to find. The only step that was different is we plugged in our molarity, and we know we have to plug it in this way because moles have to cancel. Okay. So now we know the volume of our sulfuric acid solution. So if we take 2.792, divide it by 106 times 0.324, we should get 0.0813 liters. Okay. It asks you for this in liters, okay, but technically, if I was in the lab, I'd want to look at that as milliliters because if I had to measure out 0.0813 liters, okay, then I'm going to be using a larger device than I would want, so I would probably look at it as 81.3 milliliters. Yeah. Say that again? Yeah, it's the same thing. Yes. Yeah, and we do that. We show that version later. Yeah, it just kind of adds one more kind of step, I guess. But yeah, so he's saying, could you just take your moles of sulfuric acid here and then just find molarity? So use your molarity equation. So you know your molarity is 0.324, and then you know your moles, so you could just plug it in. But that's exactly what you're doing. It's the same thing, okay, because moles over molarity equals liters. So your moles divided by molarity equals liters. It's the same thing. All right, read this problem. Give you a second to look at it. Okay, it's on your sheet or up here if you didn't get one. Just try to think about where you might start this problem. It's a little bit different than the previous. So what's different about this one than the previous problem? What's the main difference? Yeah, there's no grams, so there's no sure starting point from what you've been doing. Okay, so previous problem we had grams, great place to start. We can go from grams to moles. We know how to do that. Okay, this one a little bit different. So this time, neither of these is a solid. So they're both solutions. Okay, so we've got to find the best place to start. So any ideas? Where do you think we would start? Okay. Are we going to be able to go anywhere with that 0.505 molarity? That's the only thing we're given? No, right? So also an indicator here is that this is what we're trying to find. Okay, so usually whatever you're trying to find, so that 0.505 molarity NaOH, that's going to be one of the last things that we plug in. Okay? So what you want to do is find what you know the most about. So what do we know the most about here? Okay. We know we have 40 milliliters of 0.505 molarity sulfuric acid. So we know two things about our sulfuric acid. Okay. So we can do this in milliliters or liters, but we'll do it in liters first. So let's move our decimal. So that would be 0.040 liters. Okay. This time what you're going to do is you're going to go from liters to moles to moles to liters. Okay. Okay, over here, this is why we did this the very beginning here, and I told you this was super important for us, right? Okay, liters times what equals moles? Molarity, right? Okay, so we saw that. We saw it this way, and we can also say that moles per liter, that is molarity, right? Okay, so we can write it like this or like this, times liters. Liters cancel, and we're left with moles. Okay, so this time that's how we're going to have to start, because we don't have grams, so we're not going to be going to the periodic table and adding up the molar mass. Okay, what we're going to do is we're going to write out that volume. So we've got 0.040 liters. Oops, this is our H2SO4. Okay. Okay, molarity is moles per liter, right? So we could say we have 0.505 moles per liter. So I encourage you, if you don't see that, just seeing the molarity, the capital M, go ahead and just write it out like this, because that's the same thing. Okay, molarity is moles per liter, so it may help you when you're trying to do your conversion. All right, so we're going to plug it in like this. Or are we going to have to flip it upside down? Okay, we need liters in the denominator, right? And it is. Okay, so we're going to take our 0.505 moles per liter. So we took liters times molarity, right? That's all we did was go times molarity. and got moles. So instead of going from grams to moles, we use the volume and the concentration in molarity to get to moles. Okay? All right, any questions on this first step? All right. So what's our second step? Is it going to change? Our mole to mole step? No, it's going to be the same. So we have moles H2SO4. So we need moles sulfuric acid. And then whatever we're trying to find is going to be on top. So we are trying to find moles NaOH. Okay, so how many moles in our balanced equation do we have of sulfuric acid? 1. Okay, NaOH, 2. So we have a 2-to-1 ratio. Okay, we have the 2 up top and the 1 down below because we know we have to be able to cancel our units. Okay. So liters cancel, moles cancel. If you were asked for moles, then you could stop here, right? You could stop at moles of our sodium hydroxide. All right, any guesses on what our last step will be? Very good. So that's our other piece of information that we're given, okay, and that we've got to use. Okay, so we can write that out as 0.505 moles per liter. Okay, so this last step is just like the previous problem. Okay, we flipped it over, right, so that our moles will be in the denominator. So we have 0.505 moles liters. Okay, so in this situation, we took molarity times liters equals moles. Exactly what we did. And then here, we're looking for liters. So that's where this came in. We took moles divided by divided by the molarity. Okay, there's our moles. This is our molarity, moles per liter, and that gave us the liters. So the answer should be 0.0800 liters. Going on. Okay, what I was going to try to show you is how to do this in millimoles. Okay, that is important when you're working on a small scale. Okay, so most of your academic institutes are working on a small scale, industry usually on a large scale. Okay, and so when you're working on a small scale, you'd rather look at millimoles because your numbers make a lot more sense. You'll be given, your answers will be in milliliters, so you'll be using, smaller devices to measure. Okay, so I'm going to show you in milliliters just so that you see this. Okay, so if we take, it's not letting me erase, so we're just going to have to leave that squiggly there. Okay, so if we take our 40 milliliters. Okay. Okay, it's the same thing. So molarity is equal to moles per liter or millimoles per milliliter. So you don't have to move the decimal or anything. You just keep it as is. Okay, the difference here is we have milliliters, so we have to have milliliters here. Okay. To me, this is almost a little easier, but we just don't talk as much about the millimoles. Okay, so we do our Now we have a 1 millimole to 2 millimole ratio. Okay. So all you do is say, instead of a 1 to 2 ratio, mole ratio, it's a 1 to 2 millimole ratio. So same thing. And then the last, you would plug in 0.505 millimoles per milliliter. So your answer is going to be in milliliters, so it should be 80.0 milliliters. Okay. So these are the same. Okay. If I asked you to find milliliters, you can use the liters and then move your decimal if you want to, or you can use millimoles and find milliliters, just straightforward. So same thing. Nothing changes. Ratios are the same. No movement of decimal there. That's a common mistake. You just start with milliliters. Sorry, it's kind of messy up there. I don't know what, this thing does not like me this year. This is what you're going to be doing in lab today. So you're going to perform a titration like I mentioned at the beginning of class. And what you're really doing is you're taking an acid, so you're going to make your acidic solution, and you're reacting it with a base, and you're neutralizing it. Okay? And so neutralization just means it's no longer acidic or basic. It's neutral. So it would have a pH, if any of you are familiar with that, of 7. Okay? This is our simple definition of neutralization. Okay? And in Chem 112, we elaborate on it further. But if you take an acid, such as HCl, this is what you're going to use today, and you take a base, such as sodium hydroxide, and you react them together in a certain amount where they will neutralize each other, you're going to form a salt plus water. Okay? So that just means, so today, after you finish your reaction, you're going to have neutralized your acidic solution, and so we can pour it down the drain. It's nothing more than salt and water. And we all know we can put sodium chloride and water down the drain, right? And this is how Miss Janice and I prevent a lot of waste in our lab. We neutralize everything. Okay, so if we have something acidic, even after you guys leave, or even we'll let students do this as well, especially organic, we get a big tub and have baking soda in there, and it will neutralize the acid to water and the salt, and then we don't have to put it in big containers and pay money to have somebody ship it off. Okay, so it just prevents having so much waste. Okay, and so we can just neutralize it. Salt and water can go down the drain, and that's that. Okay, so the only difference here, this is chapter 11 that I kind of combined with 3.8 because they're the same calculations, same idea. The only thing different is telling you you're trying to find how much would we need to neutralize an acid or a base, okay, which is what your calculation is going to be set up the same. Okay, and so this would be important to us. We could actually sit down and calculate if we wanted to. So today you could do this before lab if you wanted to. You could calculate, okay, how much am I going to need to neutralize the acid? How much base am I going to need? Okay, so we can predict this by doing the calculation. So if we're looking for a volume, so we want to know what volume of 0.750 molarity NaOH would be required to neutralize 100 milliliters of phosphoric acid. Okay, so this is a pretty strong acid here. Okay, notice that we know the concentration. So I know the concentration of the acid, okay, and then I know the concentration of the base. Okay, so all I want to find out is how much base do I need to add to the acid for it to neutralize, to form a salt plus water. Okay, so just like our previous problem, where do you think we should start here? Where do you think we'll start? Are we going to be able to do much with our 0.750? Okay. Okay, no. All right, so we're probably going to start at with our 100 mils or 0.1 liters. Okay. Do we need a balanced equation? We're going to need an equation, right? We need to know our ratio. Okay, so that's one thing we've got to show. Okay, so I've got the whole thing up here. Just look at this right now. Okay, here's our balanced equation. We have 3 moles of NaOH for every 1 of phosphoric acid. Okay, so we're going to start with what we know the most about, just like the previous problem. We've got 0.100 liters, and then we have the molarity, moles per liter. Remember, it's the same thing as molarity. So we take liters times molarity, and we get moles, right? Okay. So from that point, we do our mole to mole ratio. So we have moles of phosphoric acid up top, so we have to have moles of it on the bottom, and we have 1 mole for every 3 of NaOH. Right. Last step, now we have to plug in our molarity, and we're going to plug it in flipped upside down, if you want to think of it that way, just like we've been doing, so that our moles will cancel and we're left with liters. Okay. So we took basically we did our liters times molarity equals moles. Our first step. Here's our mole to mole ratio in the second step. And then last, we plug in our 0.750 moles per liter. That was up here, but we flip it around and put it there. So our moles cancel, and we're left with liters. Okay, so it's the same as the problem we did before, just a different equation. And it's asking you what's the volume of NaOH. So if we were in the lab, we could use our 0.100 liters or 100 milliliters. Okay? And if we added that to our acid, if we had 100 milliliters of 0.250 molarity phosphoric acid, then we would neutralize the acid with that much base. Okay? Questions? Okay. This is where you'll need your book. So if you didn't bring yours, then get next to somebody that has it. And the page number might have changed, and I may need to check that because y'all's books are different this semester. And I still have the old one. It's the same? Okay, good. Okay. 78 through 81, these are just great practice for what we've just done. So you can work individually and then talk amongst each other and try to come up with these answers, and then we'll go over them if we have time, or we'll go over them on Wednesday if we don't. Check something real quick. I want to make sure it gives you, okay, good. It gives you all the equations. Okay. Raise your hand if you've got questions or need help. passing out the exam, your grade is higher if you had bonus points. So this is just the grade for the exam, but if you had bonus points, your Blackboard grade may be higher. So if you had it and add them up on your test. Does that make sense? Grade should be correct with the bonus points, yes. Tanner. Josh. Ellie. Tanisha. You're Anthony, right? Okay. No Russell. Okay. large. That's ammonium. That's ammonia. Yeah. Yeah. So you want to start with milliliters. You can convert to liters if you want to, but that's fine, yeah. And then, so see how you have milliliters here, that has to be milliliters. Because see, those wouldn't cancel.
Okay.
So you're still in KOH, you can't be in CO2. Okay. The only way you can convert from one unit or compound to another is your mole-to-mole ratio. So draw your thing there, and then you have milliliters KOH on the bottom. Okay, so this is where I borrow this one. So this is what you know about KOH right here, as far as your, so 0.957 molarity equals millimoles over milliliters, right?
Yeah.
So there's your milliliters. So it'd be just 1. And then your millimoles is at 0.957. So all you did was plug in molarity there. And then now you'll use your ratio. So you have 2 millimole. This is KOH, right? Okay, and then what are you looking for? Okay, so then you have to put up here, this is your mole-to-mole step, how many moles of CO2 you have. So you look here, yep, so you have 1 millimole CO2 on top. Okay, so you still have one more step. So yeah, go ahead and write millimole CO2 because you know that has to be your units. Okay. Okay, so what you're going to do now is take your, so where was it? Okay, so this one, what does that say? I don't have my book. What does that say? 7 grams?
How many grams? I feel like the number of grams of carbon.
Okay, so this time you're just going to have, put it up here, so you have 1 millimole, and then up here you would have, if you're going from, see, millimoles may confuse you on this one, but we'll go ahead and finish it. So if you're trying to find grams and moles, you just add up your molar mass, right? But this is only, if you're in millimoles, you're going to have to move your decimal.
Okay.
So this one is a little more confusing of all of them if you're in milliliters. So you might want to convert to liters and then just like, but it's fine. Like once you add up CO2, so if you add that up, you're going to get 12 plus 16 plus 16, so I think it's 44. Let me check, yeah. 44.01 grams. You have to move your decimal back to milligrams. You're going to get milligrams here.
Okay.
So you would put, I think it was 4.401 times 10 to the 4th milligrams there.
Thank you.
Mm-hmm. Questions? Let me see. Is it 79 or? Okay. Okay. Where'd you get where is that coming from?
I just went ahead and did over here where we have millimoles. I mean, how many would
Okay, so you went ahead and found your moles.
Yeah.
Okay, and then did 1 to 2. Yes. See, when I do it, I would go ahead and just put it in there because that's the same thing, but that's fine. But you may want to show that to me first, and then so I know where you got that from. So yeah, your answer. If you started, did you convert to liters there, or did you stay in?
I convert.
Okay, yeah, and then you should get about 1.15 grams. Is that what you got?
I got 1.4. That's probably off.
Yeah, well, you just round up.
I was doing that one.
Okay.
No, you're right.
Yeah,
So where do you
yeah, but your molarity you're given is only has 3. So you just, yeah, it's whatever you have the least sig figs. So you just have 3 there. Let's see here. Thank you. Okay, so you started with, I think you just moved you moved your decimal the wrong way. Yeah. So if you start with, what's the problem say? 79, right? Okay. So if you have to move it back, so you have 0.05455. So you're just off by here. You're going to get 1.15 when you.
Okay.
Yeah. So that's the only thing. Mm-hmm. Oh, thank you. You got all of yours? Let's see. I see that one. 3.44. 1.15. Oh yeah, that one is, that one's the hardest one to do in milliliters. Because see, this is, if you're in millimoles, you have to be in milligrams. Yeah, so you have to move your decimal back 3 places. Because if you're in millimoles, you're in milligrams. So you're just it would be 1.15 grams. Yeah, so you just move your decimal back 3 places. We'll go over these though, so you'll see that. And then, that's good. Good job. All right, if you haven't finished these, I want you to finish them and bring them. This is what we'll start with on Wednesday. I want to be sure you all get a little break before lab, so it may take us more than 10 minutes to go over these. Okay, but please do these, bring them to class on Wednesday. Like I said, we'll start with these, And I will see you all at lab. Please do not be late. We will start our talk at 11 o'clock. And be sure you bring your lab video sheet. So I'll see you all in a few minutes.